Okay, so now we're going to move to a geometric sequence. All right, so arithmetic sequence, we were repeatedly adding or subtracting the same number to go from one term to the next. Geometric sequence is going to be a little different. We'll look at how we can find explicit formulas for this, and actually I've got recursive in there as well. Okay, so a sequence is going to be geometric if the ratio of successive terms is always the same non-zero number. What operation does ratio imply? Multiplication? What? No, ratio is division. Okay, so what this is saying is that if I take and I find the ratio from one term to the next, if I divide the second term by the first term, and then I divide the third term by the second term, if that ratio is the same always, then it's geometric. Okay? The ratio of successive terms of your geometric sequence, it's known as your common ratio. So for arithmetic sequences, we had the common difference D. For these geometric sequences, we're going to have the common ratio R. Okay? So let's say we have a sequence of 2, 4, 8, 16, 32. That's a geometric sequence with a common ratio of 2. Okay, so we're defining this in terms of division, but really we can also think of it as you're multiplying by the common ratio to go from one term to the next, right? Okay, find the first 4 terms of the sequence below and determine if it is geometric. Okay, so S sub 1 would represent the first term. That would be 3 to the power of negative 1, which is 1/3. S sub 2 would be 3 to the negative second power, which is 1/9. S sub 3 would be 3 to the negative third power, or 1/27. And S sub 4 would be 3 to the negative fourth power, 1 over 3 to the fourth. That's 1 over 81, right? Okay, so our first 4 terms are 1/3, 1/9, 1/27, 1 over 81. Is this geometric? Absolutely. And what would the common ratio be here? So if you're going from 1/3 to 1/9, you're multiplying by 1/3. To go from 1/9 to 1/27, you're multiplying by 1/3. Okay, so the common ratio is R here. You understand why they call it a common ratio, though? Like if I take the second term of 1/9 and I divide it by the first term of 1/3, that tells me what R is. Okay, 1/9 divided by 1/3 would be 1/3. Okay. No, not necessarily. Again, if we look at this one up here, it was a whole number like that. So let's look at how to find the explicit formula for these geometric sequences. All right. What you're doing here is you're repeatedly multiplying by the same number. Okay. Well, repeated multiplication can be represented with an exponent. Like if I'm always multiplying by 2 repeatedly, I can just take 2 and I can raise it to a power, and that represents the repeated multiplication of 2. So for a geometric sequence whose first term is a sub 1 and whose common ratio is r, the nth term is found by taking that first term of a sub 1 and multiplying it by the common ratio r raised to the power of n minus 1. This is the same idea of how we came up with the explicit formula for an arithmetic sequence. We took the first term and we added to it a factor of the common difference that was one less than the number term you were trying to find. It's the same thing here. We're taking the first term, we're multiplying it by r raised to a power that's one less than the term we're trying to find. Okay? So let's find the 12th term of the sequence that begins with 10, then 5, then 2.5, then 1.25. What's r here? 1/2. Okay, so if I want the 12th term, that would be represented with the notation a sub 12. That's going to equal my first term of 10 multiplied by 1/2 to the power of 12 minus 1. Or 10 times 1/2 to the 11th power. Now, not that you have to write it like this, but you could think of that. That's 10 over 2 to the 11th power. Because 1/2, when I raise that to the 11th, 1 to the 11th power is still 1. 2 to the 11th power is, of course, 2 to the 11th. And then you're multiplying that by 10. Okay, now, I don't know what 2 to the 11th is off the top of my head. Do you? Okay, I'm getting 5 over 1,024. And that is 0.00488. Yada, yada, yada. Let's keep it exact in the fraction form. Good with that? Okay. Now let's write a recursive formula for a sub n, the nth term of the sequence, or 18, 9, 4.5. Okay, so recall a recursive formula. It defines the sequence in terms of a previous term, right? And in order to define it recursively, you always have to provide one term of the sequence, which typically is the first term, right? What's the common ratio here? Yeah, it's 1/2 again. Okay, so to go from 18 to 9, you're just taking the first term, you're multiplying it by that 1/2. To go from 9 to 4.5, you're taking the second term and you're multiplying it by 1/2. So recursively speaking, we're just taking the previous term and multiplying it by our r value, right? So let's say for our recursive formula, we'll list out a sub 1 to be 18. And then if I want to find a sub n, what would that equal recursively speaking? No, you're thinking more, that's more of explicitly. So again, recursive, you're defining this by using a previous term, right? So Go ahead. A sub n minus 1. And then what are you doing with that? No, you're overthinking it. Yeah, multiply it by the 1/2, the r value. So you could write it like that, or I suppose you could say, isn't that equivalent to a sub n minus 1 divided by 2? Don't let that confuse you. You're just taking the previous term, that's what a sub n minus 1 represents, and you're multiplying it by the r value. Okay?